In this video, we'll be looking at compound interest. And with compound interest, the difference between it and simple interest is in simple interest, you're only earning money on the original amount or the principal that you originally invested. With compound interest, you actually earn money on the interest that you earn. Conversely, if you have a loan and it's compound interest, you ultimately pay back more because you pay interest on the interest that you've accrued. So let's just look at an example will probably be the best way to show you. So let's say you deposit $1,000 in a saving account at 10% compounded annually. So in general, if you see the word compounded, it's a pretty good indicator that we're going to be dealing with compound interest. Okay. If you leave it in the account for 4 years, how much would you have at the end of that 4-year period? Well, we know from our using our simple interest formulas, we can calculate that by just setting up a table over 4 years. So if we're looking for the amount, if you recall, our amount formula is equal to the principal plus the principal times the rate times the time. Right? So at the beginning of our first year, we have $1,000, and then we earn 10% over that year, over that 1 year. So at the end of the year, we're going to have $1,100. Well, that $1,100 becomes the amount that we start with in year 2. And then at the beginning of year 2, we're going to earn money on $1,100 instead of just $1,000. So we take our original principal, 1,100, and then we calculate our interest. So we take 1,100 times the 10% times that 1 year, and then we're going to end up at 1,210. So you see the amount keeps going up, and you see the interest that we earned from year 1 to year 2 was $100 because we increased from 1,000 to 1,100. And from year 3, we increased from 1,100 to 1,210. So that means we increased by $110, which was more than what we increased by over the first year because we earned interest on our interest. And in this year, we earned $121 going from 1331 going to 1331 from 1210. So you see that if you're investing, compound interest is really good, and you can see that how compound interest could really cause some problems for you if you're taking a loan. But if we're looking at mortgages, for example, most mortgages have a life of about 25 years. This would be quite tedious to calculate a 25-year mortgage. So there's hopefully a better way, and there is. Okay, so we have a formula that allows us to calculate the future value when we're dealing with compound interest. Okay, and the formula is this. So the amount, so the ultimate amount or the future value of the loan is equal to the principal times, that's what this bracket means, 1 plus the rate divided by n. Okay, so now n, this is relatively new. It's the number of times the interest is compounded per year. So in 1 year, how many times does the interest get calculated? And we'll come back to that. So again, A is the future value or the amount. P is the principal. And then in the brackets, we have 1 plus the interest rate, and we write that as a decimal. So 15% would be 0.15. And n is the number of times expressed in a year. And then we have this exponent, and it's important to note that this nt is like saying n times t. Okay, so it's the number of times interest is compounded in 1 year times the number of years, where t is the number of years. Okay, and you'll notice these different terms that come up when you're trying to figure out your n. Okay, and that's usually, for most people, that's the tricky part. So if you have a problem and it says that interest is compounded annually, well, that means once a year. So if n is the number of times interest is compounded per year and annually is once a year, your n will equal 1. Semi-annually, if you think of a semicircle, it's half a circle. So half a year, so every half year, which means that there's 2 times a year, so your n equals 2. If it's compounded monthly, well, there's 12 months in a year, so your n becomes 12. Weekly, there's 52 weeks in a year, so your n is 52. Biweekly just means every 2 weeks, so you could just take the 52 and divide it by 2, or if you wanted to be tedious, you could count 26. And then daily, there are 365 days in a year. So those are the terms that you'll most often come across. So it's important to recognize when to use what they mean in terms of calculating your n, because you actually use n twice in this formula. Okay. So let's try an example. Okay, you deposit $1,000 in a savings account at 10% compounded annually. If you leave it in the account for 4 years, how much would you have at the end of that 4-year period? So if we write out our formula, we have A equals principal times 1 plus our rate over our number of times we compound to n to the times t. Okay, so there's a lot of different components here, so let's just pick out and from the question and see if we can get all these different components. We need the principal, the rate, the compounding amounts, and the time. So our principal says you deposit $1,000 in savings, so $1,000 in savings. Okay, our rate is 10%, so we write that as a decimal, 0. You can write the 0 if it helps, but you don't need to. You can just put 0.1. Our time, or sorry, I forgot the number of times compounded. So it says compounded. If you find the word compounded, look to the right. The word to the right tells you how often, and it indicates what your n value will be. So we said annually means once per year. So our n becomes 1. Okay. If you leave it in the account for 4 years, so that is our time, because time is always measured in years. So now all we have to do is take these amounts and plug them in for our variables. So we'll take our principal was 1,000, and then the 1 just stays the same, but our r can be written as 0.1. Our n was 1. And then up here we have our n was 1 times 4 years. Okay, now here's the key. If you're using the TI-84 calculator, you can enter this whole formula just as it is, just like this, and that's probably the easiest way to do it. So if you do that, you start out here, you have 1,000, so you put 1,000, and then you have a bracket. So you put a bracket there, then you have a 1, so click on your 1, then you have plus, now 0.1, and this line here means divide, so you click divide by 1, which is there, then you have another bracket, so you close the brackets, and now to get, this is an exponent, to get into the exponents, you press this little hat here, and you put 1 times 4. Which seems ideal, except for the fact that this calculator is now going to calculate this bracket to the power of 1 and then multiply that whole thing by 4. So what I actually get my students to do is rewrite everything except calculate this part first before you enter in the calculator. So 1 times 4 is 4, and now I can just enter this in my calculator and there won't be any mistake. So I'm just going to go back to here and delete those. Okay, so we had 1,000 bracket 1 plus 0.1 divided by, so that line, 1 bracket, and then the hat, the little hat, which was right here. And now we can just put in a 4. And now if we just press enter, we get 1,464.1, which, you know, we're dealing with money, so we don't write money in that way. We say $1,464, and then we just add that zero on the end and 10 cents. Okay, so moving on, next example. You deposit $400 in a savings account at 6% compounded semi-annually. If you leave in the account for 3 years, how much would you have after 3-year period? So again, let's write our formula. So our future value is equal to our principal times 1 plus R over N, and then N times T. And over here, we're just going to put in our variables and see if we can pull them out of the question. So you deposit $400 in a savings account, that's our principal, okay? 6%, that's our rate, which we write as a decimal, 0.06. You can divide by 100, or you can move it 2 spots to the left. Compounded, so we look to the right, and it says compounded semi-annually. So semi-annually means twice a year. If we go back up, if we go here, we see that semi-annually, our N equals 2. It's compounded 2 times during the year. If you leave in the account for 3 years, so our time is 3 because it's measured in years. So now we just plug in our values for our variables, and we get A equals 400 is our principal. The 1 stays the same. Our rate was 0.06. Our N was 2. And then we had, we had our N was 2 times our T, which was 3. Now, again, before we plug in the calculator, we want to calculate the exponent, and then we can just enter it all in one fell swoop, and it prevents errors. So we had 400 to the bracket plus, or 1 plus 0.06 divided by 2, and 2 times 3 gives us 6. Okay, now we can enter that in the TI-84. So we have 400, then we have a bracket. So I put my bracket, 1 plus 0.06 divided by, that's what this line is, 2, bracket. And now I want to get my exponent, so I'll use the hat button, press 6, press enter, and that gives us 477.6209. But again, we're dealing with dollars and cents, so we know in dollars and cents there's only 2 decimal places. So since this is a 0, we're just going to round that to 62. So this equals $477.62. Okay. Serena wants to borrow $3,000 from a family member and pay it back in 2 years. She agrees to borrow the money at 6% compounded monthly. How much will she have to pay the family member at the end of the 2-year period? Okay, so let's write out our formula. And let's line up the variables that we need to know. Okay, so Serena wants to borrow $3,000 from a family member. So $3,000. Pay it back in 2 years. That's our time. She agrees to borrow the money at 6%. We know that's our rate, 0.06 as a decimal. Compounded, look to the right, monthly. If we go back here, monthly, there's 12 months in a year, so our N equals 2. Or sorry, 12. Okay, now we plug in our values for our variables. So we have 3,000 is equal to 1 plus 0.06 divided by our N was 12 because it was compounded monthly. And then N was 12 times 2 years was 2. Okay, now again, calculate the exponent first before we enter it in the calculator. 3,000, 1 plus 0.06 divided by 12, and 12 times 2 is 24. Now enter the calculator. So 3,000 bracket 1 plus 0.06 divided by 12, close bracket, use the hat to get the exponent, 24 equals 3,381, and again, 2 decimal places, but that's a 9, so that means it's closer to 48 than 47, so we're going to round this up to 48. So 3,381, and we're dealing with dollars, 48 cents. Okay, so she'll pay $3,381.48 at the end of the 2-year period. So she has to pay back that original 3,000 plus the interest. Kendrick wants to invest 3,000 for 6 years. Okay, we might as well just get right into it. We know it's going to be compounded, so principal, rate, compounding time, and time. Write out our variables, our principal, our rate, compounding time, and our time. So the principal, Kendrick wants to invest 3,000. So that's how much he's starting with for 6 years. Time in years is 6. Investment plan A pays 10% per annum simple interest. Investment plan B pays 10% compounded daily. So our first formula, or right now, because we just jumped straight into the compounding, we're calculating investment plan B. Okay, so our rate is 10%, so 0.10. Compounded, that's our indication that we have to use this formula right here. So compounded daily, and there's 365 days in a year, so 365. Now we plug that in, plug in our variable, our amounts, 3,000, 1 plus 0.1, n is 365, and then 365 times 6. Okay, so if we do that, again, we want to multiply this exponent first before we enter it. 3,000, 1 plus 0.1, 365, and 365 times 6 is 2,190. And now we can enter that. So we have 3,000, 1 plus 0.1 divided by 365, exponent 2,190, gives us 5,465, and we round that to 91 cents. Okay, so that's plan B, right? But we have 2 options here. We also had plan A, per annum simple interest. Okay, so if we wanted to calculate that in simple interest terms, we're going to use our simple interest formula for amount. And if you remember, amount, when it's simple interest, is our principal plus our interest, which is our principal times rate times time. So we can use the same amounts. Our principal is still 3,000. The rate was still 10%. And the years were still 6 years. So we can use all those amounts. We just don't have to worry about the n because we're not doing compounding. So plugging that in, our principal was 3,000 plus our principal was 3,000 again. Our rate was 10% and our time was 6 years. Then we do our bed mass and we get that equals to 1,800. And then 3,000 plus 1,800 equals $4,800. So if you're investing, you want your A to be bigger. So which plan would you go with? Well, you can compare. Plan B with compound interest gave you almost $5,500. Simple interest gave you almost $700 less. So go with plan B. It's the compound interest. All right. So just the key is when you're punching, just to remember, when you punch it in on your calculator, calculate the exponent first before you punch all of this in your calculator. But lay out your formula, and then over here, write your variables that you need, and then pull them out from the question. Okay, if you have questions, see your instructor.